Good morning. My name is Barishi. Anak perempuan Pharmacy 1, my matric number is 16D M21F1072. Today, I'm going to talk about my lab 2 about venturimeter. My lecturer name is Nurina Ami binti Ramli. So this is the rubric of my report. So now let's see the experiment outcome. The experiment outcome is to determine the relationship of the pressure drop versus the flow rate in the venturimeter and convert the pressure drop reading into flow rate. So the theory of this experiment is the Venturi effect is the reduction in fluid pressure that results when a fluid flows through a constricted section of pipe. As fluid flows through a venturi, the expansion and compression of the fluids cause the pressure inside the venturi to change. The velocity of the fluids increases as the cross-sectional area decreases to satisfy the equation of continuity, while its pressure must decrease due to the conservation of energy. So this figure 1 shows the methods to measure pressure drop by venturimeter. This one is using manometer, this one is using electronic sensor. So an equation of the drop in pressure due to Venturi effect may be derived from a combination of Bernoulli principle and the equation of continuity, measurement of volumetric flow rate as below. So this is the other equation. So this is the unit and calculation tips. So let's see objective. Okay, the objective of the experiment is, at the end of the lab section, students should be able to determine the coefficient of discharge of given venturimeter to be able to professional in venturimeter. Now let's see the apparatus and equipment. First is venturimeter, second differential manometer, third collecting tank, fourth piezometer, fifth stopwatch, sixth measuring scale. Safety and precaution, make sure the student follows the manual instruction in laboratory shift. So now let's see the procedure. First, open the venturimeter experiments link. A window will appear as shown. Select the required diameter of pipe, then click Next button. Click on the main inlet valve to allow the flow through it. Then click on the pipe inlet valve to allow the flow through it. Click on manometer node to change it from isolated position to air vent position to remove air bubbles, and again click to change it to root position. Here the manometer reading is noted down. Then calculate the value of head loss. Click on the tank outlet valve to close it to measure the discharge. The observation and calculations of the trial is given here. Calculate the actual discharge, theoretical discharge, and coefficient of discharge. Repeat the same procedure for other trials. So this one is step 1. You must select the required diameter. Then you must open the inlet valve to allow water through the selected diameter pipe. This one is step 2. This one step 3. Step 4. Step 5. Step 3. Okay, now let's see the stimulation. Okay, the objective to determine coefficient of discharge of given venturimeter, apparatus to use, venturimeter, different manometer, collecting tank, piezometer, stopwatch, and measuring scales. In step 1, a pipe of required diameter is selected and others are kept in the closed position. Select the pipe of required diameter. So first we select of 20 mm. The diameter of pipe is 20 mm, length of pipe is 3 meter. Step 2. The main inlet valve is open to allow to flow through the selected diameter pipe. Open the pipe valve and change the knot manometer from isolated position to air vent position to remove air inside the pipe. Now open this. Click here. So second, we open the pipe valve to change the knot of manometer. Now air vent position, isolate position to air vent position. Next, the knob is then kept in the red position and note down the manometer. Okay, right now it's in the red position. So what we get is left limb reading is 42 centimeter, right limb reading is 40 centimeter. Now let's search of head loss. Head loss is left limb reading minus right limb reading, then times it 12.6. So 42 minus 40, we get 2 times 12 times 6, we get 25.2. Check. Then go on. Step water is not allowed to flow through the selected venturimeter, and this flow is made constant at this flow rate. The difference in pressure between inlet and fluid is measured. Step 5. Exit valve of collecting tank is closed, and time taken for the tank water to rise by 5 cm is noted. So time required by water to fill 5 cm height is 95 seconds. So this is the observation. D1, D2, area 1, area 2, rise, time taken, head loss, acceleration due to gravity. Now, first it was actual discharge. Let's get the actual. Actual discharge, the formula is area of collecting tank times the rise divided time taken. 6750 times 5 divide 1995. We get 355.26. 326. Check. So it's correct. Now we theoretical discharge. Now let's see the theoretical discharge. The formula is area 1 times area 2 times square root of 2 times acceleration due to gravity and head loss. Divide by square root area 1 minus area 2. Area 1 cube minus area 2 cube. So I get 3, 6, 2, no. So the answer we get is 36.46. Okay, now let's get the coefficient discharge. Discharge is actual theoretical divided theoretical discharge. 355.26 divide 363.46. I get 0. Check it. Okay. So this is the folder. 20 millimeters. Now the steps are repeated. The steps are repeated for the 20, 40, 50 are the same. So what I get from the stimulation for 20 mm is actual discharge is 355.26, theoretical discharge is 363.46, coefficient of discharge is 0.98. For 40 millimeter, I get 253.7, 253.7.59 for axial discharge, 2877.164 for theoretical discharge, 0.88 for coefficient of discharge, and 50 for 50 diameter is actual discharge I get 2812.5, theoretical discharge I get 3448.2673, coefficient of discharge I get 0.82. So the calculation of theoretical discharge is for 20 mm, the same as I do, area 1 times area 2 times square root over 2 times gravity times head loss, divide by square root area 1 minus cube area 2. So 3.14 times 1.5 times square root 2 times 981 times 25.20 divide cube root bracket 3142 cube square minus 1.5 square bracket. I get 355.26 centimeter cube per second. So same as goes to the 40 meter, I get 2877.1643 centimeter cube per second. For 50 meter, I get 2812.5 centimeter cube per second. So for the second, discuss an observation of each differential reading for actual theoretical reading, theoretical for actual discharge, theoretical discharge, and coefficient of discharge. So these are the observation for 20 meter. The observation, this is the observation for 40 mm. These are the observation for 50 mm. So let's see the conclusion and recommendation. The experiment was done successfully. From this experiment, I learned about coefficient of discharge of flow, which the volume flow rate of water to flow to water given the cross-section area, the result shown, and my observation. I had found the value of price H for all diameter pipes are same reach 5 cm. Moreover, I learned the discharge of coefficient meter is typically 0.985. But maybe even higher if convergent section is machined. From this lab work, I have been learned to calculate the formula of coefficients of discharge, axial discharge, and theoretical discharge, and head loss. That's all from me. Thank you.